Hi everyone, this is Mr. West, and this is a Khan Academy tutorial covering the volume and surface area word problems. This is an activity on Khan Academy related to geometry. Let's go ahead and get started. Emily convinced her mom to buy a giant box of her favorite cereal. Not a bad plan by Emily. Her mom doesn't think the box will fit on their shelf. The volume of the box is 10,000 centimeters cubed. Notice how with volume you have cubic units. The base of the box is 25 centimeters by 10 centimeters. Okay, how tall is the box of cereal? So what we need here is we're given certain attributes of the volume of the box, and it tells us we're working on volume. Obviously, this is between volume and surface area, these problems. This time we're concentrating on volume because it says volume. So our formula for volume, and this is, so it's talking about a box, okay? When we're talking about a box, we're talking about a rectangular prism, of which the volume is equal to the length times the width times the depth, where length, I mean, it doesn't really matter. I usually like to consider length and width as the two-dimensional shapes, and then the depth as the one that goes in or out, the depth, to make it 3D. You might also see it as length times width times height, where it's just labeled a little bit differently. It's the same thing though, okay? So this would be the width, this would be the length, and then this would be the height. So a couple different ways to think about it. The important thing is the formula still stays the same. It's all the dimensions multiplied together. That being said, we can, whoops, wrong pencil. We can formulate this process a little bit more clearly. I'm gonna use depth, because that's what I say, and I'm doing this video, so I'm the boss. Now I'm just going to plug in these different values. So 10,000 I'm going to put in for volume. This is the part that kind of trips people up the most, I think, is when they see that just because we normally input stuff here doesn't mean we can input something for volume. In this case, that's what we're doing, is we're inputting 10,000 in for the volume, and we're solving for a different dimension. It asks us, it wants to find how tall it is. So in this case, we're talking about the length, or in this one, the height, but we're not using that one. So we have 10,000 there for our volume. The length is what we're looking for. So this is going to remain unsolved for a while. It's our unsolved mystery. And now it doesn't matter between these two. 25 and 10. We could call one the width, the other the depth. It doesn't matter. I'm just going to call it interchangeably. Well, forgot my L. Need to take an L on that one. And then 25 times 10, interchangeable. It's important to double check to make sure these are all the same units, and they are, minus this one's cubic units because it's a measure of volume. Okay, let's go ahead and simplify this a little bit. So we have L times 250, and that is equal to 10,000. Okay, now what we do from here is we isolate L by dividing both sides by 250, and we should get 40. But let's double check. 10,000. Another way to do this problem, if you don't have a calculator, is you cross off the 0, and then we have 1,000 divided by 25. Well, I know 100 divided by 25 is 4, so 1,000 divided by 25 is going to be 40. So that's a way to do this problem without a calculator. So we have 40 equals L. Now, the units are centimeters, and keep in mind the reason why the volume is centimeters cubed is because we're multiplying centimeters times centimeters times centimeters. You go over this more in chemistry, actually, converting units, at least I did, but that's how you find cubic units. You multiply them together, so we're going to hit 40. Sorry, I spent too much time on one point. Let's move on. Ooh, really good one here. A theater wants to build movable steps that they can use to go on stage and off stage. That's one thing I like about surface area and volume, super applicable. They want the steps to have enough space inside so they can also be used to store props. Smart. How much space is inside these steps? Okay, when we're talking about space inside, it wants you to differentiate or decide which of these two things is it, volume or surface area. Space inside, key word here, and then also space. Okay, so space inside is volume. Okay, so volume is the space inside. So we know we're going to be using a volume formula. Now, This one's going to be a little tricky because, yes, we have rectangular prisms, of which we know this is the formula, the 3 dimensions, but we have multiple dimensions here because it's a couple different, 2 different rectangular prisms. I think the easiest way probably to divide it up would be to divide it like this. So we have this 3D prism right here. I'm finishing the outline. I would recommend doing an outline. It just kind of helps you see the shape a little bit more clearly. So there's our outline of our first prism, and I'm going to redraw it over here. Why do I always use yellow? It can be hard to see. So I hope your lights are turned off in your room because it might be hard to see this. And then I'm going to go green for the smaller one, the first step. Okay, so I hope you can see the 2 different, I hope that helped you see the 2 different boxes, rectangular prisms. So now we're just going to multiply the dimensions for both of these. So this one's formula, oh sorry, and then for our total volume, that's this V right here. I'm going to do, you can't see where I'm pointing at you, for this V right here, we're going to do the volume of the yellow plus the volume of the green, and that's going to be the volume of it all, okay, then of the steps. We can call it steps, okay, S. So let's go ahead and find each of these volumes. So this volume is going to be equal to length times width times depth. We know the length, we'll call that 0.3. So 0.3 is our L. What else? I'm confused on what dimensions these are. Oh, okay, so this is the, we'll actually need to do the green first. Let's do the green first because we're missing some dimensions for the L if you haven't noticed. Okay, so a couple dimensions we know for the green. This is 0.2. Okay, so 0.2, we're going to call that our width. Volume equals length times width times depth. We know that that's 0.2 in the middle. And then we have this, what do I call that? I call that the L. So that's L, that's width. So the L is times 0.15. And then we have our depth, which is 0.5. So I'm going to multiply all these together. 0.5 times 0.2 times 0.15. My students always get confused on this. When you multiply multiple decimals together, you're going to get a smaller decimal, 0.15. Okay, so there's my volume, and the units are meters cubed. Okay, so I'm done with my green. That one's set. Now it's going to be a matter of finding out the yellow. Now, if this is 0.2, that means this is 0.2 on this side also, meaning if this whole thing is 0.4, that makes this distance right here 0.4 minus 0.2, which is 0.2. So this is 0.2 for the width. We're going to call that the width. 0.2. Now the last thing is the depth. What is the depth? Well, it looks like it's the same length of stair on both sides, so this is also going to be 0.5. So we're going to put point times 0.5, and that's going to be our depth times 0.5. So now we just multiply these together, 0.3 times 0.2 times 0.5, and we get 0.03. 0.03. And now we just add these two together. So we have 0.03 plus 0.015, and we're going to get 0.045. Volume equals 0.03, just so you can see it, 0.015 equals 0.045. Finally, answer meters cubed. 0.045. Check it. Next question. Hopefully do a surface area. Oh, it's another volume. Aubrey has a new art box in the shape of a rectangular prism. Cool. The box is 12 by 20 by 5. The only thing in the art box is a new pink eraser with the dimensions shown below. What is the volume of the art box not taken up by the eraser? Okay, so this is the eraser. It gets this whole problem set up right here for the box. So the volume of the box is going to be equal to length times width times depth, right? 12 times 20 times 5. And it doesn't matter because you're just commutative property. You just multiply them together. So that's essentially 12 times 5 is 60 times 20. 6 times 2 is 12. I'm just showing you another way to do it without a calculator. It's important. 1, 2, 0. So 1,200. Okay, so now we have the, we have to concern ourselves with the eraser. So now we have this dimension. We'll use green now. And we want to find the volume of this guy, length times width times depth. And same units, double check, okay? We're going to have 4 times 2 times 0.5. I'll multiply 0.5 times 2, which is 1. 4 times 1 is just 4. Okay, so what is the volume of the art box not taken up by the eraser? You just subtract the 2. Okay, we're looking for the space around it, so the volume of the empty space, ES, is equal to the volume of the box minus the volume of the eraser. So that is 1200 minus 4. And that is going to be, was that 1,196? Why am I not writing anything? Okay. 1,196. There we go. Centimeters cubed, 1,196. Check it. Next question, last one. Give me surface area, please. Hassan built a fence around a square yard. It took 48 meters squared of lumber to build the fence. The fence is 1.5 meters tall. What is the area of the yard inside the fence? Ah, interesting. Okay. We want the area inside the fence. So this is a surface area problem, finally. Okay, so Hassan built a fence around a square yard. It took 48 meters squared of lumber to build the fence. We're talking about the surface area here. So look here. We have the height is 1.5. Okay, so 1.5. Keep in mind that the surface area, okay, aka the total amount of lumber needed. It's the same thing, surface area and the total amount of lumber needed, because we're considering a two-dimensional space, okay? Surface area is going to be equal to the area of one of those sides, so we'll call that area of the rectangle, and then how many are there? It's a square fence, so that means they're the same dimensions all the way around. Okay, each side is. Each length, I should say. So that means we're just going to multiply this times 4. So the area of the rectangle times 4 is equal to the surface area. Now, the area of the rectangle is going to be equal to, let me put this here, 1.5 times L. Well, guess what? We don't know what L is. That's the whole point. We want to find the dimensions of the yard in order to find the area of the yard. In order to find, we'll make the yard green. Look at that nice green grass, okay? In order to find the area of that green space, we have to know the two dimensions, L and L, okay? That's how we find the area inside there, okay? That's going to be the area inside our yard. So let's go ahead and write that. Area of the yard equals L times L, aka L squared. But we need to find that L first. So we're going to express the area of the rectangle in terms of L. It's going to be equal to the length times the width. Well, we know the width, or the height in this case. Area of the rectangle is equal to L times 1.5. So I'm going to put L times 1.5, and we multiply this by 4 because there's 4 of them there, and that's equal to our surface area, 48. Okay, and I'll highlight that just so you can see it. That's 48, so that's why that's 48. Lumber to build the fence, surface area. Okay, what I'm going to do here is I'm going to multiply 4 times 1.5. That's essentially taking half of 4 and adding it on, so that's 6. So 6L, I don't like the L being first, so I'm going to rewrite it in just a second, equals 48. So 48 equals 6L. We divide by 6 to get L by itself, and we get L equals 8. Okay, we're almost done. So now that we have L equals 8, that means it's 8 meters in length. We can plug it in to our yard formula, and so we get area of the yard equals 8 squared, 64 meters squared for the yard. Check it. And we're done. 100%. Look at that. Awesome. You leveled up. Hope you enjoyed this video. Kind of a longer one, but worthwhile, hopefully, for you. Thanks for watching. Be sure to check out more videos. Leave a comment if you need a specific topic covered. I'm all ears. Talk to you later.